columns, because when you create models, you can also see how correlated your data is through the model. And then if stuff's not correlated, if stuff is useless, you can drop it, then your algorithm will become more accurate. So, all right, so we talked a lot about this, but okay, so the engineering, I'm kind of breaking down these different areas in a kind of a different slice, I guess. The model and algorithm building. Okay, that's one part of your job as a data scientist. Some parts more or less than others. Like for instance, first part, the algorithm development. That's not something everybody's going to be doing, but some will be, at least, and will be all contributing to it, if not directly, indirectly, by using and talking about these different algorithms. So how did these algorithms develop? How did they come about from scratch? The first thing was, okay, we had a problem. Somebody said, okay, I want to predict this. We didn't just develop these algorithms without there being a problem already. Or like a big example would be new number, numerical recognition. You present it with a picture of a number, and okay, what number is that? That's a problem. So then some people sat around and said, okay, how are we going to solve this? And they talked about the approach of creating the algorithm. How do we want to do this? And I guess the next part, are we going to build on a simpler algorithm? Like for instance, go from tree, simple tree algorithm to boosted tree. That's where you're taking a very simple algorithm and making it more complicated. Or are we going to take an existing algorithm and add to it? That's another way an algorithm is developed. Another hyperparameter, perhaps, another feature that requires a hyperparameter, I should say. And hyperparameter is a tuning method. Like for instance, and we'll get to this with neural networks, is how many neurons. That would be a hyperparameter. That wouldn't necessarily be an extra feature. Maybe a hidden layer, add a hidden layer. That's a new feature to neural networks. Let me think, what else? All right, so that's how algorithms develop. Okay, so all right, another part of algorithm building is this abstraction process, which this is probably one of the things I like the least. However, it's life, so I have to get on with it. And it's hiding away the underpinnings of a process, a model, an algorithm. That's you don't. In other words, you don't have to recreate that algorithm every single time from scratch with the mathematics. You can just plug in a function as a black box, and that's great. And one of the things that's a big advantage of that is whoever created that abstraction, whoever did the mathematics, did the programming, did it perhaps very efficiently. And it will always get better. Somebody's always going to be working on it, making it better. So it will become faster, more useful. So if you, and you don't have to worry about that. But over time, you can get numb to how it works, how it works underneath. So, which, you lose some information, some usefulness of these algorithms when you do that. So some of the abstractions that are out there, scikit-learn, you have many model algorithms, models/algorithms there for you to use. Many functions, it's all built. TensorFlow is one of the most recent, and it's very excited. A lot of people love it. It makes creating neural networks, it makes all this matrix mathematics, it makes it all very easy to use and fast. And you're able to offload this stuff off of your processor, perhaps, through APIs. Use AWS or Google, because you're just saying, I need a neural network. I need another layer added. This is how I want it to look. Keras is even a higher abstraction. You're not even involved with the math. It's super simple. We will go through all of these as we go further, as we get further in a couple weeks, because that's where on a day-to-day basis, that's how you're going to be applying your models, is through these different abstractions. And as you can see, there are more than just those three. Those are the ones that I would say, I don't know if they're the most popular, but they are definitely becoming popular. As you can see, TensorFlow is new and it just took off. This is all just as of 2016. Keras is newer than that, newer than this graph. Sorry about that. I should find another graph to replace that. But scikit-learn's been around for a while, and other ones are coming up there. But it's like they're all, I won't say they're the same thing, but they all have the same idea in mind, to give you a tool set of machine learning algorithms to pull from. So other things you do as a, on the computer, is what are you running it on? What hardware are you using? Are you running it on your machine? Are you running it on, do you have a GPU where you're able to take advantage of speed up in processing, the faster processor? Because we will get into this when we get to the mathematics. Actually, today we should be able to get into that in the time. Okay, what are the calculations that are going on? There are just a few calculations that are just happening over and over and over and over and over again, gazillions at a time. So if you can have a very fast processor to run that, not a very complicated processor, but one that's just specializing in multiplication, then that's extremely advantageous. So you have a new thing coming out where you're able to take advantage of that, and we will look at that. It's fascinating on how that works, how you set up the parallel processing to do some of the work. Are you running it on AWS? This is something. It's just, are you running it on your own machine, or are you running on a cloud machine? AWS or the Google AI Cloud. It's just the way to do it. I mean, for any size of problem, your machine's pretty limited unless you've spent, a nice penny on it. So might as well take advantage of somebody else's machine for pennies. A few dollars, I guess. Okay, something else you do for the building in the engineering, and you're also using mathematics, is making your algorithm faster. Not necessarily from running it on a faster machine, but you know, seeing where your memory can be used more efficiently, perhaps, or use less instructions. So that's something else you can do. With not much of us will be doing that. Okay.